Anyway, this is recent advances in networking. So this first class is basically to answer these 5 questions. Why this course? What are we going to teach? When? And what are we going to do the project and the grading part? So the goals of this course. Recent networking topics. Now the technology is moving very fast. By the time you have finished the course on any topic, you know that you are behind. Because a lot of things have happened in that 3 months, in that 1 year, in that 2 years when you got your master's, PhD or whatever, or 5 years or 4 years for PhD. You are behind. And so there is so much going on, particularly in the internet and the networking. Not only the internet causing all these changes, but it is also the source of change itself. And so this course is designed to cover up as much as we can what has happened in the last 2 to 5 years. And in particular, I want to make sure that people, when they get out of here from WashU, they can find a job. Because you have taken a course in networking, you have done a PhD in networking, you have done a master's in networking, but you get there and they ask you, what do you know about big data? What do you know about cloud computing? Or what do you know about other things that we have in this course? And you say, sorry, that is advanced. I haven't done that one. Well, sorry, we don't need you right now. And so if you want to get a job in the industry, in the academics it is different, by the way. In the academics, all it counts is your PhD thesis and how you give a talk. But that will not count when you go to an industry. They don't ask you to give a talk in the first place. They just ask you the questions. Right? And if you can't answer them, then they just don't want you. So this is about a comprehensive course, covers many topics. And those topics are listed here to begin with: data center networking, virtualization, software-defined networking, big data, cloud computing, Internet of Things. And the problem is each of these is a big topic. I could give a whole semester course on big data and not finish it. It's so big, right? I could give a whole semester course on any of the other topics: data center networking, software-defined networking, cloud computing, Internet of Things, and not finish it. However, at WashU and in our life, we don't have that much time to take 6 courses in 6 semesters, so we have to finish all of this in 1 semester. Right? And therefore, this is what we call a breadth-first course. Breadth-first course means that we are going to cover a lot of topics. And if you find one topic interesting, if you need to get into one topic, you go into depth, in your way. And we will teach you how to go into depth, because that is where the project comes in. You go into one topic in depth more than anybody else in the class. Okay? But you know about all other 5 topics. And that way, when you go to a company interview and they are interested in Internet of Things, within 2 days you can become an expert in Internet of Things. And you have a depth knowledge of that. And that is what is required today. Because you have to be able to get the knowledge very fast. The knowledge is coming so fast. The knowledge is being developed so fast. Internet has made it possible for us to get things fast. Right? And papers can be written. We used to take 3 years to write a paper. We published a paper in 3 years. That was good. Today, you write 3 papers in a year, maybe 30 papers in a year. It's so easy. There are hundreds of journals, hundreds of things. All you have to do is have a website and you have a journal. Right? And you are writing papers and they are published on the website. There is no paper involved. It's free for them. It's just, you pay them $500 and you're done. And so the knowledge is coming so fast at us that we really have to be able to get it fast as well. The brains are not becoming any faster at the Moore's law. Right? So we have to get it faster. And that's what this is. This is breadth first. Now, since this is a graduate course, I want to make sure that you do a graduate level work, which means you have to do a lot of reading. By the way, there are no books really on these topics, many of these topics. Actually, there are books, to be fair about it, but the books are, by the time they are written, by the time they come into your hand, they are 3 years old information. And a lot has happened in those 3 years. The latest book, you pick up the book which is dated 2013, it has information which is dated 2010. And in 2013, the industry is working on totally different topics. Here in the university, we are still teaching the same. All right? We don't move as fast as the industry does. Believe it or not, this is true. We can't, because we have to wait for the books to come in. And so that is what this course is about, is not having the books and being able to get the information as we can. So there is a project, survey paper. Some of you have taken courses with me before. I see few faces. Those are very familiar with the project part, and this will be just a repeat of that. All right? But some of you, and actually majority of you, have not taken any courses with me before. For you, this project part is important. I mean, listen about it. Project is important for everybody anyway. So first of all, because of the internet, we don't do anything physically anymore. Everything is virtual. Right? You want to go to office, you don't go office physically, you just work from home, and that is your virtual office. You want to go to shopping, I don't go shopping at all, but I buy a lot of stuff, all from Amazon and other places, sitting at home, virtual shopping. Entertainment, whatever you want to watch, whether it is a movie or anything else, it's all there on your computer, at your place, wherever you are. You don't have to go to the theater. Education, this course, you are here physically, but you really don't have to be. A lot of students will be listening to the same lecture in different countries. Recording of this lecture, by the way, this lecture is being recorded in different places without coming here. Right? And so, everything is virtual today. The workplace is virtual, the shopping is virtual, the education is virtual, and computing is virtual, and everything else is virtual, right? And you're looking for that word? Yes, that is virtual too. Right? So everything is virtual, and the reason is why everything is virtual. Actually, why virtual is not a question, but that also means that everything in the technology is also virtual. This is all made possible that the technology itself is virtual. So as we'll see, we need virtual networks, we need virtual internet, we need virtual computers, we need virtual storage, we need virtual disks. So we don't need anything physical anymore. Physical is much more difficult. The life is very fast. The life is very fast. In fact, in 1 minute, 60 seconds, 204 million emails are sent. Now, you can't keep up with your email. This is because of the internet. It's because so many of them come to you every minute. 2 million searches are done on Google. We live on Google, most of us. And Facebook is the next place where most of us live. Many of us live. Just can't get off the Facebook. 350 gigabyte of data is added to Facebook every minute. Video is added to YouTube at the rate of 72 hours per minute. So in 1 minute, they load up 52 hours, 72 hours times 60 minutes, right? 270,000 tweets on Twitter, and 15,000 songs are downloaded from iTunes. A lot of things happen, as you can see, and obviously all of this relates to knowledge as well. I could write here how many papers are written every minute, how many things are done, but that is the rate you can see. And obviously, the reason for all this is that everything is becoming fast. Everything is becoming fast. Today, you all know Moore's law, right? I don't have to tell you Moore's law, right? If you are in computer science, you have heard of the Moore's law, Gordon Moore. And he said that the computers become twice as fast every 18 months to 2 years, and they are becoming fast. And over so many years that has passed since his saying, the computers are so fast today that basically that's why the computers become out of date within 2 years, because you cannot live with a computer which is as fast as half of your neighbor who just bought the computer, right? So you have to buy computers very, very often, and that has some effect that, as we'll see, that's why we need a virtual computer rather than a real computer, because virtual computers don't have to become slow. Real computers can become slow. So first thing is the computers are becoming very fast, and that has many effects, and that will tell us why we need software-defined networking, why we need virtualization, why we need many things. Okay. In addition to the computers, the storage is becoming very high capacity. Maybe not be becoming very fast. Actually, it is becoming very fast too, but the capacity is going through the roof. Few years ago, we used to buy disk in gigabytes. This year, you don't talk in gigabyte. You carry terabytes in your pocket. When I go to travel anywhere, I carry at least 1 2 terabyte disk, and then maybe more than one. Okay, 2 terabytes has become kind of a standard disk size nowadays. And so terabytes, petabytes, exabytes, they're just coming like anything. Right? And obviously disk has become very fast with SSD coming in. And so we don't measure the capacity of the disk by how many kilobytes per second, how many megabytes per second. Now they are talking about 500 megabytes per second write speed. Now turn that into bits, and then you will see 500 megabytes. And multiply by 8, you get 4 gigabits per second write speed. All right. And there are two events that I want to point out that have changed the life of the computer networking people. One is which happened on August 25th, 2006. What happened on that day? Amazon announced EC2. So what is EC2? EC2 is Elastic Cloud, Elastic Computing Cloud, number 2. And basically what happened was that the Amazon, which is a big company with a lot of sales, the president went to the data center and he was surprised. The data center is like a football field, as you will later on learn in data center networking. It's a big football field with thousands of computers in there. And he said, so many computers, why do we need so many computers? And the people said, well, when there is a big overhead, like in December, in Christmas time, big not overhead. When there is a big surge of purchases, we need all these computers. So what do we do 11 months when there is no Christmas? Do nothing. Just sit there. They said, why don't we rent it out for the 11 months? And this guy is very smart. He actually rents out everything that he has extra. He doesn't leave anything unused. If you want to sell on Amazon, they will do shipping for you. They rent out their shipping facilities. Obviously, they sell for you, and they can do everything for you. So he said, why don't we rent out the computers? And so the computer renting business started by Amazon is today called cloud computing. It was not invented by Google. It was not invented by Microsoft. It was not invented by IBM. It was invented by a retailer who didn't have the use for their computers, and they said, why don't we rent it out? All right, and cloud computing has changed the world today. Everybody is in cloud computing business. Every company is using clouds. Every company that is in the networking business or computing business is selling clouds. Second thing that changed the world is June 29, 2007, when Apple announced iPhone. We had lots of smartphones before iPhone, by the way. I had smartphones for years, but they were not really smart by today's standard. We could run some programs, but the number of programs was 5, 10, 2. And those programs had to be bought from the same, so on and so forth. But the whole app market changed the whole world. Today there are millions of apps. There are so many things we can do. And suddenly the internet has changed. Suddenly the internet has come into your hands. Right? That raises new issues. And that takes us to Cisco. Cisco is a big networking company, and they keep track of what is going on in the real world very closely. Every year they publish what they call VNI, Visual Networking Index. Every year. So the VNI for 2013 has this list, which I took. Actually, this is very small part of that big report. You can download it. By the way, every slide has, and most of the slides have references on the bottom. And so the URLs are there, so you can go and yourself look up more, and you have to go and look up more because I can't cover everything in the 1 hour and a half that I have. So I give you the key, and then you can find out more. So Cisco BNI. In 2012, just the mobile data traffic was 885 what they call petabytes. And since we can't remember really peta, we haven't used it that much, I put 10 raised to 15 there, just to make it easy for you. Okay? 885 petabytes. And which was 12 times that was in 2000, and it will be now 10 exabyte exabyte in 2017. Exa is 10 raised to 18. It's going very fast. Out of that, it turns out most of that traffic is video. A lot of us are doing FaceTime. No, actually, a lot of doing, a lot of watching movie, Netflix, or whatever, right on our phone, or YouTube, for that matter. 51%. So more than half of the traffic is video. That shows you some trends, because now, if most of the traffic is video, the networking people have to get started in business of, making better videos. Better video traffic transmission. A smartphone generates 50 times the traffic of a basic phone, and will be 2.7 gigabyte per month per phone. Now, right now, when I use my phone, my bill comes out 200 megabyte. My son's comes out 4 gigabyte, by the way. But that is what will be for everybody in 2017. Right? 2.7 gigabyte per month per phone. 4G connection generate, so the more you get, more you use. 4G connection generate 19 times the traffic of a non-4G. So everything else, like 3G and 2G and whatnot, they generate 19 times. 4G generates something. And Android generates more than iPhone. Now, iPhone was the one that really started this whole thing, but now it has gotten behind. There are more Android phones, obviously, as you know. And per Android phone, there is more traffic. Per Android phone. It's not the total Android phone traffic. Because there are more applications, maybe. And the number of users is 3.6 billion, will be 3.6 billion. Now, the world population is total 6 billion or something like that, or 4 to 6 billion somewhere. So, 3.6 billion internet users in 2017. And every user will have lots of devices. So, I right now, for example, have 2 computers, 1 phone, 3 right here, and maybe if you go to my office, it will be in 10. Go to my home, there will be 10 more. So I have 20 devices, and so now you add up, 3.6 billion users, and an average user, the total number of devices will be 19 billion. However, these devices are not just the phone and computer. Everything in your home will be interconnected to the internet, because if you are not connected to the internet, you are not smart. And so every device will be smart, and your refrigerator will be connected to the internet. Your heater will be connected to the internet. Your door will be connected to the internet. Everything will be connected to the internet. Obviously, all the security cameras, are connected to the internet. So there will be so many devices from home that you'll be able to control virtually from anywhere. See, that's where the virtuality comes in that, all the devices will be, you could be anywhere. You don't have to be physically at home to see who is entering your home. You could greet anybody from anywhere, right? So the idea is that the number of devices is going up, and the traffic obviously is going to go to 1.4 times 10 raised to 21. What is that number? Anybody knows 10 raised to 21? Anybody? Nobody knows 10 raised to 21? I told you petabyte, exabyte. What comes after exabyte? Zettabyte, right? Did you say what? Zettabyte. Yeah. Z is in zebra. Okay? So zettabytes. Now learn these numbers, because that is where we are getting it, so fast. So that many bytes will be entering the traffic in 2017, up from 0.5 zettabyte right now. Then another place we look for what is happening in the industry is Gartner. What is Gartner? Gartner is the company whose job is to forecast. And their reports are sold for $5,000 to $50,000 a piece. I and you cannot buy it, and we don't even think about it. But every company, like Cisco, IBM, Microsoft, they buy all Gartner reports, because that is how they decide what to do next year. right? If Gartner tells them that the traffic will go up, this and that, and so on and so forth, they just decide what to do for that traffic. And so Gartner has a very famous hype cycle. Hype cycle has several stages. These stages are given here in the bottom. Innovation trigger. This is where the technology is just coming into the world. These are the technology just coming into the world. Once they take shape, then they start rising very fast. They go to the peak. Everybody loves them. And then it's like a wedding, wedding. Everybody, this is the pre-wedding time. Everybody loves the other person. And then the wedding happens and then they don't love anymore. Right? But they love, but then they say, oh, there is some problem here, there is some compromise to be made. So the technology falls, like my laser pointer. So technology falls, and then the technology goes to zero, and some technology survive, and they go to normal life. And then they live happily hereafter. All right. Now, as a researcher, your preference should be to be on this side of the curve. As a company, your preference would be to be on this side of the curve, because you don't want to be on this side of the curve. On this side of the curve, big companies make money. I mean, the small companies, the startups, are companies. Actually, even the big companies can't make that much money. So they really want to be on this side. So everybody wants to be on this side of the curve. All right. As an individual, you need to be on this side. As a company, you need to be on this side. As an educational institution, you need to be on this side. Everybody needs to be on this side. The technologies which are here, they are going into the hype phase. Hype phase. That means everybody is thinking that this is where the money is going to be. And I have put few arrows here that we will cover. And so here it says Internet of Things. Right? Now, Internet of Things is almost coming towards the peak. It is not at the peak right now. But if you go to some company or some investors or some VC and say, well, I have a proposal for you for this Internet of Things, they will say, oh, beloved, give it to us. Tell us what it is. But this is where the money is going. Second arrow goes to big data. Big data is at the peak. Lot of investment has already been made. All right? And we don't know where it is going to go. Even the Gartner doesn't know. And in fact, this graph is all Gartner's creation. So, I mean, you have to take with, as they say, with whatever you call the amount of salt or something like that, is that this is their view, and they are not really gods, right? I mean, nobody knows exactly what it is going to happen. So this is their view. But this is, according to their view, big data is almost at the peak. Third arrow I have put. Where is the third arrow? Can anybody see the third arrow? Right here. Third arrow is cloud computing. Cloud computing is now old, 2006. Now it is, I don't know of a company which is not offering, it is into too much of competition. There are actually, in one place I saw a list of 100 cloud service providers. Can you imagine? Starting with Amazon, now there are 100 cloud service providers. So it has gone through that whole phase. A lot of investment was made, and now it will come back, and some few companies will survive, and it will be history. I mean, it will remain. Cloud computing is not going to go away. It's not going to go to zero. It's going to just become a normal thing. Any questions so far? By the way, I have a slide on grading later on. However, I want to just point out one part of that grading is that 5% of the marks, 5 points out of 100 are reserved for class participation. And some of you know already. Class participation means asking questions and answering questions. If you answer a question which I asked, you get a point. If you ask a question, you get a point. Okay? So make sure you get a point at least for asking the question. Alright, that means talk. That means make it a bidirectional communication. That means, just don't listen. Ask if you have a question. But one more thing. Not much of this, particularly for this course, there's no textbook. If you have a question, the best place is to now. Ask it now. Because when you go home and you say, oh, I didn't understand, what did he say, Jetta? Too bad. All right. So, is there any question on this cycle? Yeah.
Could there be some areas which are shown on this slope?
Yeah.
Enlightenment, but there are aspects of it which could still be on the high phase.
Oh yeah. So the question was, I will repeat the question, that when they have put a topic like big data, now big data is big, as we said, it has many pieces, as you will learn. Some pieces might be at the bottom of the curve, some pieces might be at the top, some pieces might be on the other side. So yes, that is true. That is true, because this is just a picture. In fact, what they do, Gartner also does, is they have a similar hype cycle graph for individual technologies. So if you are a networking company, you can go and say, well, give me the hype cycle for the networking. And then only thing on that graph would be networking, nothing else. Different types of networking. Okay? Any other question? Yeah.
Yeah, I saw from the slides that there are some dark blue circles that says the plateau of that product will be reach the plateau within 5 to 10 years. And my question is that how come that there are some dark blue products at a different portion of the curve?
Yeah, okay. So the plateau will be reached, they are saying, for this particular product, which are blue, plateau will be reached in 5 to 10 years. This will be much faster, 2 to 5 years, and this will be less than 2 years. So how fast they will go to the, to the whatever the curve they are crossing.
Yeah, but some of the products at the very beginning.
Yeah, that's true, but they might be rising very fast. The thing is, every product doesn't have to take 5 years to get there.
I see.
Okay? All right, I'm going to move off this, come back to the course. So one thing is that, I wanted to teach a lot of stuff, and I may teach a lot of stuff, but what I decided was that there are 6 topics that clearly deserve discussion in this course. So I listed those 6 topics, and I will go through those 6 first, and if there is a time, we might go to more, and so on and so forth. So first topic is data center networking, second is virtualization, third is big data, fourth is cloud computing, fifth is software defined networking, sixth is Internet of Things. And for each I have the slides. I'm going to go through the slide. Data center networking, we'll talk about how are the data center networks different from those in your home or office. So you use Ethernet at your home, right? Everybody uses it at home. If you don't have Ethernet, I don't know what else you have, maybe Wi-Fi, but most of us have Ethernet. At the offices, obviously, we have Ethernet, but Ethernet is also used in data center. Is it the same Ethernet? Is there a difference? Is there a difference in anything? Cabling, wiring, protocols, standards? That's the question we'll answer, right? What are the standards for data center layout? If you go to a data center, how they manage it? How have the Ethernet other protocols have been changed to accommodate data centers? Why connect multiple data center by single Ethernet? Now the current trend is that you could have a data center on this part of in medical school, and you could have one in here, and they would look like one data center. Why? Why do you want to make multiple data centers look like one data center? You could have one in Boston and one in here and look like one. Why? And that takes us to the next topic, virtualization. So the question is, why virtualize in the first place? I already gave you enough reasons that today in our life we don't do anything in physical sense, we just do in the virtual sense. So the question is, why virtualize? Why virtualize anything, right? So we'll answer that. And then the question is, if we decided to virtualize, how are the servers virtualized? Servers means computers. How is the storage virtualized? The disks and the tapes. What is the networking components? What networking components are virtualized and how? So networks has routers, switches, NICs. But if anybody knows what is a NIC? What is a NIC? Yeah, NIC, Network Interface Card. So those of you who didn't know should have asked. But so NICs are to be standard to be virtualized. Everything has to be virtualized. What are the new networking standards related to virtualization? So what are the industry doing, right? Cloud computing. What is cloud computing? How is it different? What are the different types of cloud services? How is the cloud different from grid computing or cluster computing and other places? What new technology is required to enable cloud computing? Why the cloud computing was not there before Amazon? What did come that made it possible? Now everybody is in a cloud, but before that we were not. What new thing happened? What is fog versus cloud computing? Now Cisco is now saying we are beyond cloud computing. Cloud computing is past. Remember that graph bottom? Cloud was in the bottom. Well, the new word is fog computing. What is the difference between fog and cloud? Cloud is up there. Fog is right here. Right? And everybody knows what is a fog. All right. Moving on to software-defined networking. What is software-defined networking? How is the industry running to adopt? Why is the industry running to adopt this new technology so fast? So VMware bought the first SDN company to be established for $1.2 billion. VMware has a total market value of $3 billion, which they made after 10 or 20 years of hard work. Now they spent 1.3 of that in buying a SDN company. Must be something hard there. Cisco has put $800 million or promised to buy a company for $800 million, their own internal startup on SDN. And every other company that I know of, you name any networking company, whether it is Juniper or whether it is, whatever, Microsoft or any other company, they are all working on SDN. What is this? Why this craziness? What new facilities are enabled by SDN? So what can you do that you cannot do today? How is SDN different from network function virtualization? So there is another thing going on called network function virtualization. How is it different? What is the difference between SDN and OpenFlow? Now, there is a protocol called OpenFlow, and a lot of people think that is SDN, but what is the difference? What are different flavors of SDN? Now, SDN is not just one kind, there are many kinds. Okay? Now, questions? Moving on. Internet of Things. What is so unique about Internet of Things? By the way, Internet of Things means interneting everything. In fact, Cisco calls it IoE, Internet of Everything, where everything includes your refrigerator, your watch, your heating system, your cooling system, anything in your home, washing machine, everything will be on the internet. Because if it is not internet, it is not really, it's like connecting to electric power. Without electric, you cannot do anything. Without internet, you cannot really deal with any device anymore. And so Internet of Everything. What is so unique about it? Why can't we just connect them like that, right? What are the new IEEE IETF protocols for IoT? So everybody is working. By the way, two organizations that develop the protocols are IEEE. Anybody knows what is IEEE? IEEE is a conference. Anybody else? It's an organization. Yeah. So those of you who didn't know, please ask. Okay? IEEE is Institution of Electrical and Electronic Engineers, and you should all be members of IEEE by now, because IEEE, I became member when I was a student, and I am a member still for the last how many years. That is where most of the journals are published from. Most of the conferences are organized by IEEE, respected conferences. If the conference is sponsored by IEEE, we think it is a good conference. The second organization similar is ACM, Automatic Computing Machinery. So you have to be a member of ACM and IEEE. As a professional, this is a professional society. But what one thing does, IEEE also develops a standard, and it started with Ethernet. By the way, I was involved in the Ethernet standard, so I know the whole early story. It started with Ethernet, and now there are many, many standards related to Ethernet and that layer that are done by IEEE. So all Ethernet standards obviously come from IEEE, but Wi-Fi and anything else which is at the layer 2 comes from IEEE. And IETF is what? What is IETF? Now, not those two guys, but anybody else. Anybody knows IETF? No. So if you took 473, I'm really surprised that you didn't come across IETF at all in 473. Anybody who took 473 here in WashU? And they didn't mention IETF?
They published RFCs.
Yeah.
IETF, yeah,
we talk about it. Yeah, right. Okay, all right. So what he said was that IETF is actually, which is Internet Engineering Task Force, is the one that publishes RFC, request for comment, which is basically a standards for everything other than layer 2. Layer 3, 4, 5. And 5 includes 6, 7 anyway. So if you have any protocol, which is application protocol or transport protocol or networking protocol, it has to be approved by IETF. So they have developed it, right? What technology are required for web of things? So now in interneting of things, they also have web of things. What is it and why? What is required? WOT. And what are the different kinds of things? Machine to machine, sensors, RFID. RFID. Anybody knows what is RFID? Hold on. I got to get other people 4 marks. Otherwise, they will get 0. Anybody else know RFID? Okay, go ahead.
It's like a radio frequency identification.
Yeah, radio frequency identity. Anytime you buy anything from Walmart, they don't read anymore. They just pass it by because the radio frequencies can read it. That little mark, which everything has nowadays, is called RFID. Okay. Now RFID may not be really electronic RFID to be sure. UPC symbol is not RFID, but many of the devices have a thing which can basically be read by the RF. Okay. Some of them are read by visual, like there must be just simple simple UPC can be read by light, which is visible light. RFID is radio frequency. So those things can also be used for interneting, because once something comes up in your garage, it passes through some RFID scanner. It says, oh, okay, the refrigerator has arrived. It has been delivered. So now you can figure out where the refrigerator is. And, or any other thing for that matter, Your book, you take your book into your room, the book has an RFID into it, and then, you know where the book is. You don't have to, you just go to your computer, Google it. Not Google it, really do an internal desktop search, and it will tell you the book is in the bedroom. Things like that. And so on and so forth. How can the cloud help IoT? So IoT, everybody is going to use cloud. Mobiles are using the cloud, and you can see why the IoT can use the cloud. Big data. Am I going backwards? Okay. What is big data? What is sudden interest in big data? What are the key technologies for big data? And how can networking help in big data problems? What are the relationship between the clouds and big data? I'm going to go a little bit faster here because I'm only halfway through my 40 slides. Non-goals. So there are few things I had put in the project in the description in the beginning when I was planning to offer this course. By the way, this course has never been offered before, and it may not be offered again, because by the time it is offered again, things will change. So when I wrote this course description a few months ago, I had put some wireless and security stuff, which I am not going to cover here. Reason is that we have a course on wireless. Whatever the latest in the wireless will be covered in the wireless course. Whatever the latest in security will be covered in the security course. The problem in covering in this course is because all you have done is taken 473, you have not taken wireless. And so it will be very difficult for me to explain you 5G when you don't know 3G or 2G. Understand? So we are not going to do wireless, we are not going to do security, and so there are security issues with everything. If you pick up a book on big data, there is security issues with big data. You pick up a book on cloud computing, there is a security issue with cloud computing. We are not going to talk about those, sorry. All right, because we have to first cover security before we talk about security of the cloud. Okay, clear? And if that is what you came here for, good time to drop. Reading material. So there would be a lot of readings from technical papers, industry white papers, standards document, and biggest of all, Wikipedia. Wikipedia is updated on the day things happen. If there is yesterday's news, you can go and find it on Wikipedia today, believe it or not. Okay? If somebody moved from somewhere to somebody, some big known name, you just go to the Wikipedia page and it will be written that, oh, he was caught, he was, Snowden, for example. You want to know about Snowden, where he is today, this minute, go to Wikipedia. Okay? So we'll make use a lot of that, and then books. I have gone through hundreds of books, and obviously there are no satisfactory books, but 3 books came very close to being satisfactory to me. So I wrote them down here. They are not required list, but each of them covers a topic to the extent that I will be using a lot of it. All right, so I put them here. This is what we call reference list, reference book. You don't have to buy it, but this is where the material will be coming from, and I will put the reference on every page on everything where the material is coming from. All right, very many different sources. Networking courses WUSTL. By the way, there are many courses at WUSTL in networking. Here's the complete list. Everything requires 473. If you have not taken 473, don't even bother with this course. This will not make any sense. Don't even bother with any other networking course because it will not make any sense. So 473 is a must. Now here's what you need to know. You need to know what is an ISO model, what is a TCP IP stack model, what was the LAN addressing, what is unicast addressing, multicast addressing, what is local versus global, what is an extended LAN, what is the difference between bridges, hubs, routers and switches, what is a VLAN, what is IPv4 versus IPv6 addressing, what is the public address versus private addresses, what is a subnet, what is ARP, what is ICMP, how is the TCP connection set up, what is a slow start, how is TCP different from UDP, and how does HTTP work. All right, that's a big list. That's not a big list. Actually, this is a very small part of what is taught in 473, but these are the topics that I know I'm going to need it right away. All right, that may turn off some of you, but I want you to be safe rather than sorry. All right, you don't want to go through the course and then find out you cannot handle it. Schedule. So here's the day-by-day schedule. It will not be followed because we don't know how much we'll cover today, let alone tomorrow. All right. So, but this is roughly, I do it so that I know that I can cover it. So we will have 2 or 3 classes on data center, 2 or 3, 4 classes on network virtualization, and so on and so forth. It continues on the 2nd, 3rd, 4th page. The main thing is to remember that the exam 1, the first exam is on 9/30, September 30th. And these dates are fixed. The exam will happen regardless of where we are in terms of covering. Whatever we cover will be in the exam. Whatever we don't cover will not be in the exam. But the date will not change. So mark that date in your calendar. Don't be sick on that day. All right? Don't plan to go anywhere for in that date. Don't set up an interview because I will not change the date. And second exam is on 11/4. And you can see big data, cloud computing. And third exam, the final exam is on 12/11. And that 12/11 is before the exam period. It is on the final, is the last class before the reading. So it's in the class time, okay? During the class time. And you can see the things. Every exam covers whatever has been covered from the last exam to that exam. So it's not cumulative, it's just incremental. So, projects. Now, as I said, you need both breadth and the depth. Breadth I provide, depth you provide. All right? Everyone has to do a hands-on project or a survey paper related to one of the 6 topics. Some hands-on projects and survey paper will be assigned. So what I do is I will give you a list of topics and you can select one of them. If you have some topic you think yourself, you come up with it, you can come to me and say, can I do a paper on this or can I do a hands-on project on this? Hands-on project means that you set up something either on your own computer or on my computer or on our computers, in the lab computers, and you can say, well, I'm showing you this big data thing. I'm showing you this cloud thing. You can do it on the computers. You do that, or you can write a paper. Some you can suggest for approval. And I expect that you will be spending about 6 hours per week on the project. Okay? And 9 hours. 15 hours per week. When you have a 3-credit course, we expect you to spend 15 hours a week. And so that's what it is. And obviously all the projects will be something which is 2 to 4 years, so which is even newer than what I teach in the class. What I am teaching in the class, as I said, is breadth, and even though it is 2 to 5 years, but yours will be really last month, last year, very recent. All the papers will be published on websites. So whatever you write, they go on my website. Some of you have seen my website, others of you have not, please go. You'll find hundreds of papers written by students like you in my previous classes. Every class students write the paper, and they are put on my website, and then they are copied by the rest of the world as their homework. And some of them are published as papers by other people as well. I mean, I have seen papers which are just copies of our papers. But this is something that we are very proud of, and we want to make sure that you write a good work. Better ones can be submitted to magazines or journals. Okay. Examples of projects: setting up and using a Hadoop cluster for big data analysis. So you can set up a cluster in our lab if you need more than one computer. Setting up or using a cloudlet using OpenStack. Setting up, so on and so forth. And we are working on those still more. And the list. This is not the list. We will provide you more list, and you can think about it along these lines. The project schedule is that October 7th you will have to select the topic. References will be due on 14th. The outline of the project will be due on 28th. Final paper is due on 11/18. And all the papers will be reviewed by your peers, by other people in the class. And the reviews will be written on 25th, and the revised reports will be due on 12/2. So those dates are all fixed. Yeah.
For the hands-on projects, is there papers?
No, for a hands-on project you write a report though. So when you do something, you will write a report that this is what I have done, and this is how I did. These are the problems that I ran into, and here's the codes. Very often people have done something which resulted in new code. So that basically the idea is that everything has to be repeatable. So somebody else can read your report and be able to do that. Right? And generally we don't keep anything secret, so we even publish our code. People can download and repeat it themselves. If you have developed a code.
Is it individual project?
Okay, the projects can be individual or can be in groups of 2 maximum. It can be bigger group. Exceptions can be made if you come up with a big project, but basically it has to be justified why you need so many people, because then the project management becomes an issue. So you can do in groups of 2 if you were doing. In general, what we have seen in the past, all the survey papers are written individually, but all the hands-on projects are done in groups of 2. Homeworks, all the homeworks have to be submitted on Monday. And any late submission is always have a penalty. So if you say, well, I was sick or I went there and I had to do this and that, whatever reason, it doesn't matter. If it is not on Monday here, it is an extra work on us. We have to especially grade your homework at a time when we have totally forgotten about that homework. We pass on some of our pain to you by penalty. So you also feel painful for doing anything late. Generally, we don't accept the late anyway, but you have a very valid reason that you had to go for this interview and this and that, whatever reason you had, there will be a penalty. Please write in the subject field. If you send, so all the homeworks have to be submitted in hard copy right here in the class. Some of them, like today's homework, which is if we get there, has to be submitted by email, and that email we will not get there. But email has to has a particular subject field. Okay. All homeworks are identified by the class handout number. So the homeworks are numbered, they are not consecutively numbered, homework 1, 2, 3, 4, 5. You will see the number, whatever number it says, you just say it is 15, that's 15, period. So numbering is on our side. And all homeworks will be on a separate sheet, and you said, so you cannot just submit 14, 15, 16 together, and then we are trying to figure out whether it is together, it is separate. Please, just keep it separate. Office hours 1 to 2 p.m. My teaching assistant Paras, please get up. So he is our TA, and his information is here. And Swarti, he is our level 2 TA. We have level 1, level 2, like processor caches, level 1, level 2, level 3. If Paras cannot handle it, he will pass it on to Swarti. If Swarti cannot handle it, he will pass it on to me. Okay, so you start with Paras first. Grading 60%. Is best of the first 2 exams. Oh, actually, 30% is for the final, 30% of the first 2. So the first 2 exams are really, you need only 1. Okay? So if you, for some reason, could not come to the first one, for some reason you got sick or something, you still have second exam. And it doesn't matter whether you made the first or the second or both. I don't penalize people for not being sick. So the people who were not sick can take both exams. Okay, and then do whatever best they have. And so that in class, so the final is, there is no repetition for final. After the final exam, I just leave the country every single time. Okay, so I won't be here, and you won't be able to take the exam again. So that is fixed. 60%, so that is 60%. Class participation is 5%, homework is 15%, project is 20%. Any question?
The final is 30.
Huh?
The final is 30.
Final is 30, best of midterm is 30. And best means, if you got 13 in one and 13%, and the second one you got 15%, 15% will count. Okay, I do use a curve. Your grade depends upon the performance of the rest of the class. So you cannot say whether if I got 70, will I get an A grade? I don't know. If the whole class got 70, then there is very difficult reason for me to give somebody B, somebody A. So basically what happens is, once the end of the class, we find out where the class is, 50% get an A, 50% get an A, 50% don't get an A. Alright? And every detail will be presented to you. Some of you have taken my courses and they know that it is all very open, transparent process. You know your grade before it happens because you can do the Excel worksheet as well as I can do. Okay? And so you will see the marks and the grading and everything else that, basically these people are statistically different. So they need a different grade. And so basically it depends upon how the class does. All homeworks are due on the following Monday. We talked about that and so on and so forth. I think, all the exams are not open book, but they are open one sheet. You can bring one sheet of paper with written holes, both sides in microprint. Everything, whole book copies onto one side, that's fine with me. But one sheet only. Okay? 8.5 by 11, both sides. Alright. So file type means that what type of result you are looking in Google. If you are just looking for PDF, tell it. If you are just looking for PPT, tell it. Okay? So you are looking for Raj Jain, you say Raj Jain plus file type : PDF. You will find all my papers right there. Because all papers are written in PDF. Right? And so on and so forth. If you are looking for cloud computing and you are looking only for things which are in PDF, generally PDF has much higher quality material than HTM. HTM is blogs, PDFs are reports. Right? So if you are looking for some thing, you just look that. Site is WUSTL.com. Not WUSTL.com. Okay, well, this is a new company. WUSTL.edu is what we have. If you're just looking for something from WUSTL.edu, you put that site WUSTL.edu. What has been done in WUSTL related to cloud computing? In title, trend. I'm looking for anything which has in the title trend. So the word trend has to appear not in the contents, in the title. In URL, it has to appear in the URL. And now URL is kind of very arbitrary, so generally we don't use in the URL. But if you are looking for CSE 570 in the URL, then you can just put that in. All in title. So you put all the words in the title are all in the URL, and then you put a quotation, means I mean exactly this, nothing else. So if you say cloud computing, it will find, Google will find something where cloud is here and the computing is there. But you don't want that. You want cloud and computing together. Right? So you put any quotes. Or you can say cloud or fog. It will find both. Cloud and fog, it will find which has both. Alright? And if you have and or are for some reason, say for example you want to find out Raj Jain and his wife, that you will not get, because Google is thinking that you are looking for his wife, and Raj Jain, so it will appear anywhere. Right? So if you really want and is used for as an operator. If you want to use it not as an operator, what do you do? Put it in the quotes. So you do like this. You can say cloud computing and Cisco. Well, that's that. And once you put in the quote, it has to be exactly in that same order. They have to find a paper or website which has cloud computing and Cisco as it is, right? With the word and in there. Alright? Must include plus. If you put a plus file type, that is a must. If you put a minus, should not include. So I want to get everything from on cloud computing, but not from WUSTL. Alright, so you put a minus site WUSTL. Okay, I want everything in cloud, but not the computing. So cloud minus computing. Alright, minus Similar. Now you don't know what cloud is similar to, so you say like similar, that tilde word X. And then star. I don't care, cloud, star, computing. So whatever is between the two, it doesn't matter. So all these things, how many of you have used all of these or knew all of these? How many of you knew all of these? Just be honest. It doesn't want to increase your mark, but just want to know. 3 of you, because you have taken my course before. Basically, all 3 of you have done this before. This was the first homework in every course I teach. Okay? So, this is the homework. And now it will be due on Wednesday. The homework is for you to do Google search. Actually, you have to do search, not Google search. You have to do search. And you have to search the web pages, books, and journal articles. And this is required for your, in general, your life. I'm just giving you this first homework because you will find that this is very valuable to you, whatever you do in life today. Whether you are doing research or doing anything else, you should be able to do this. And I do this every day. Is you have to find the articles from IEEE Explorer, ACM Digital Library, Mobius, Safari Books, Iliad. Now, how many of you know these words? Before I go any further. All right, 3 of you out. Anybody else? All right, if you don't, it's 1 person over there. Good. So, what is Mobius for? No, not you. I think the person behind you raised his hand. In Missouri. MO is for Missouri. So, if a book is in anywhere in Missouri, you can get it from our library. All right, and that's why I put there. Safari is a whole set of books which WUSTL subscribes to. If there is a book in the Safari books, you can get it here. Not only get it here, you can get it at your home instantly. You can read it right there. Okay. Iliad. Iliad is, anybody has heard of it before? No. Interlibrary loan. If it is anywhere in the United States, you can get it in WUSTL without any charge. They will get it for you. Okay? ACM Digital Library in IEEE Explorer. What is IEEE Explorer? This is where all the IEEE sponsored general conferences, papers, transactions, everything is stored at. And that is where you will find most of the information that you are looking technical papers. Same thing for ACM Library. All of these are available for free here at WUSTL. All right? They are not available free from your home. From your home, you have to log in into WUSTL via VPN. Then you can get it. Right? And the library is a proxy too. Otherwise, the best thing is to just come to WUSTL and from any connection, from any port, from any wireless, you can connect. I think not any wireless, some wireless, because I think guests probably are not allowed. You can use these resources. But you have to know how to. That's where you need to go to the library book site, which is library.wustl.edu, and look up for Mobius, look up for Safari, look up for Iliad, blah, blah, blah. All right? You will find it very useful in your other classes as well. But on this course, this is the first thing you need to do. And what you are searching for? You are searching for the things that they are going to teach you. Networking trends, data center networking, network virtualization, cloud computing, software-defined networking. I have already done all of this, but I just want you to get started as well, because in case you need to go to depth. Not all of them, just one of them. So you do just select whatever topic suits you best and do this search. And you have to try these things. You have to try library.wustl.edu, find out. This is the library website, main library. This is the full text library. So they have lots of ebooks. All right, ebooks, again, same thing like Safari books, you can read them. Scholar.google.com. What is Scholar? So Google searches generally are from the companies mostly, but they're not papers. If you really want papers from Google, you go to scholar.google.com. Books.google.com. If you're looking for a book, most of the time you don't have to go to Amazon or any place, just go to google.books and you can read it just like Safari books, except that Google will decide which pages to show you. So you are reading from page 231, 232, 233, suddenly it will not show you 234. Go ahead and buy it, they say. Okay, but they will show you some pages. If you're lucky, you might be able to get the whole chapter. If you're not lucky, then there will one page will be missing. But they are available. Books are good. DL ACM, this is the ACM digital library. Cyrus and search. So go ahead and try all of these things. You will find different things, there at different places for the same term. Ignore all the entries that are 2008 or before. So I don't want anything which is more than 5 years old. Do not indicate the topic or similar words that do not indicate the topic or similar. So here's the thing, though. I don't want to see cloud computing will come up, like 1,000 entries, and you will select any 5, and Google will present you any 5. I don't want any of that. I want to see that the title itself somehow gives me an idea that this is relevant thing right now, right? And I'm asking you for 5, so it should be easy because, there is, for example, if you're looking for cloud performance, you will find books that have cloud in chapter 1 and performance, in some chapter 13, and that's not cloud performance. Right? So basically I want something that is obvious that it is related to the topic that you're talking about. And so I want 5 of the books, 5 of the web pages, 5 of the technical magazine articles. Now what is the difference between web page and magazine article? It should be obvious. Web pages are, like company Cisco website or something, or blog or something else you find it very interesting. But the technical articles are papers which are published in a conference. Right? This will have a conference citation. For the books, include whether the book is available at WUSTL or Mobius, Safari or Iliad. So you have to go back with the books and see where you can find it. You can see why I'm asking you to do all this. Is because whenever you want to find a book, this is what I have to do every single day. Serially number the references and submit electronically to Jain at CSE. This is the only assignment, actually one of the few assignments that will be by email, and you serve subject field of CSE 70 or homework number 1. And please be careful with this with the subject field. My email is read by the machine. If you mistype it, it doesn't have a spelling checker. If you miss a space, it doesn't have a spelling checker. So make sure that you write it exactly as I said. Okay? And please note subject carefully. Do not any correcting subject. Your answer should be content of the message, and don't put it in an attachment. Just put it in the message. Okay? I don't want a doc file, PDF file or anything. I just want a text done right there. Make a list of other interesting search points and share in the class. And then if you find something which is not on my list, let me know. How does it look? Can you do it? Any question?
So five for each means for each topic?
Not each topic, one topic. Any topic you select, for that you need 15 things. For one topic you need 15. You cannot take 5 here, 5 there, 5 there. You need whatever topic you select, 5 things. 15 things, yeah. Go ahead.
How do I know I submitted my homework successfully?
Yeah, because when I return it, you won't get it back. So then you say, oh, I submitted it, and then here's my email, I sent whatever, proof. Hopefully, when we come to the class next Wednesday, I would, okay, but before, by the way, all the homeworks are due before the class, right? I said that. So if you bring it here, you put it here. In this case, you are not bringing it here, but 1 o'clock when we come to the class, I will ask, is there anybody who has not submitted? If your name is not in that list, I expect that you would be there, right? And so I will go and check it. I won't be able to check in the class, but after the class. Any other question? We've got plenty of time. So we can take a quiz. Now open this page on your handout. And these are 11 questions which are true and false. And you have to just mark true or false. Now, here's the good thing about this quiz. I am not going to see the answer. So if you don't know the answer, you only know that you don't know the answer. If you know the answer, you only know that you know the answer. But at the end, we will grade the quiz, and this will help you decide whether you have the enough background or not. All right? So go ahead and freely, correctly make the answer. Now here's one more trick, one more thing, rule about this quiz, and this is rule about all the exams and the quizzes. How we grade them. if it is a multiple choice question, this was in one of the earlier slides, if it is a multiple choice question and there are n choices, for the correct answer we give you 1 mark, for the incorrect answer we give you -1 upon n minus 1, 1 upon n minus 1 mark, I think, right, or 1 upon n minus plus 1 marks, -1 upon n, 2 choices, -1, I forgot. Let's see, let's go back to that slide. Right here. For the correct answer +1, for the incorrect answer -1 upon n minus 1. Okay? For 2 choices, all you get is +1 for the correct and -1 for incorrect. If you don't answer it, it is 0. All right, so we do the quiz. 11 questions. You can do that, and as soon as you're done, please